Alright, we're starting a new chapter today, and the name of the chapter is Relations and Functions. We're going to be on this chapter for quite a bit of time, and definitely some new information that you really haven't had any prerequisites for. Alright, so let's start with the definition of what a relation is. A relation is a group of ordered pairs. So an example of a relation, I could say that relation A is defined by the set of ordered pairs 0, 1, 1, 3, and 2, 5. So this is a relation because it's a group of ordered pairs. In fact, it's 3 ordered pairs. So a relation can have any number of ordered pairs, and relations can be expressed 4 different ways. In relation form, you can express it as a table of values, as a mapping, and as a graph. So a table of values is just listing the x and y values, connecting the x value with its appropriate output value. So we have the order pair 0, 1, the order pair 1, 3, and the order pair 2, 5. In a mapping, it's just a different way to list our x and y values, and it's using an arrow to connect the input with the output. And this is really cool notation because it's saying 0 turns into y, 1 turns into 3, 2 turns into 5. And that's really illustrating the input-output relationship for relations and functions. And a graph, and I'm just going to sketch this graph. The order pair 0, 1, the order pair 1, 3, and the order pair 2, 5. So here are 4 different ways to express the same relation A in set notation, table, mapping, and a graph. The domain of a relation are all the possible x terms. So the domain of A was 0, 1, 2. All of the possible x values. The range, all possible y values. So the range of A was 1, 3, 5. 1, 3, 5. 1, 3, 5. So a function is a specific type of relation. Oh, forgot the U. It's a relation which has no repeating x terms. Notice how it says nothing about the y terms. It has no repeating x terms. So let's call relation A the set of ordered pairs 1, 3, 2, 3, and 2, 4. Let's express this relation as a table, a mapping, and a graph. Before we do that, let's determine whether or not it is a function. In order to determine if it is a function, simply have to look at the x terms. 1, 2, 2. They're all repeating x terms, so this is not a function. It is just a relation. Now, a relation may be a function. A function is always a relation. It's a specific type of relation, in which there are no repeating x terms. So let's express this as a table, a mapping, and a graph. Table, let's just list the x and y values as we see them. 1, 3, 2, 3, and 2, 4. The mapping, let's just list our x and y's. 1, 2. The difference between a table and a mapping is that a table, you're listing it as you see it, and a mapping, you're not repeating. I already wrote a 2, so I don't need to repeat myself. I'm just going to have more arrows coming from 2 than I need. 3, 3, 4, so I'm just going to list 3, 4. So really what you're doing with the mapping, you're listing the domain and the range. So now we have to go back to our order pair or our table of values to determine 1 turns into what? Well, 1 turns into 3, so draw an arrow there. 2 also turns into 3. But 2 turns into 4. So here's our mapping, and this shows 1 turns into 3, 2 turns into 3, but also 2 turns into 4. So this is not a function because there are repeating x terms. There are 2 arrows coming from the 2. There are repeating x terms in the table. There are repeating x terms in the set of ordered pairs. But if you have a graph, there's an easy way to determine if a relation is a function. Let's plot those ordered pairs. 1, 3, 2, 3, 2, 4. The vertical line test is a test to determine if a relation is a function. And the way the vertical line test works, if I can draw a vertical line through the graph and pass through more than one point, then the graph is not a function. And really what you're doing by drawing a vertical line, you're testing for repeating x values. Because this vertical line is a vertical line that represents x equals 2. This is x equals 1. So this is saying I have 2x equals 2. If I draw a vertical line through these 2 points, I'm going to touch it more than once, which means x equals 2 repeats. Well, there's the x equals 2 repeating. There's the x equals 2 repeating. Here's the x equals 2 repeating. And here's the x equals 2 repeating. So you should be able to determine if a relation is a function regardless of how it's listed. As an ordered pair, look at the x values. As a table, look at the x values. As a mapping, look for the arrows coming from the x values. And as a graph, you're going to use the vertical line test. One more quick thing, if we have graphs that are not just integers, if we have graphs that include all of the values between integers, making a line, or a parabola, or a circle even, I could still use the vertical line test to determine if these graphs are functions. So in this case, no matter where I draw a vertical line, I will never pass the graph more than once. Now I'm not talking about the axes here, I'm talking about the graph itself. So we're drawing a line and seeing, are we going to pass this more than once? No, so this is a function because it passes the vertical line test. In this case, if I draw a vertical line through the parabola, I will never pass the graph